All right, we are at section 10.8, energy considerations in rotational motion. Let's share the PowerPoint, and we've got this force applied to this object. So you see the work done is the F sine phi is the is that portion of the force that's along the line of ds. You can see the ds there. Well, ds is equal to rd theta. So the force dot ds is F sine phi times rd theta. So dw equals to the torque d theta. So F sine phi r is equal to the torque, and dw dt is equal to the torque d theta dt. Well, what is d theta dt? That's omega. So the power, which is the time rate of change of work, power is equal to dw dt equals t omega. I mean tau omega. I'm sorry. Okay, so the torque is equal to I alpha. The sum of the torques is I alpha equals I. What is alpha? Alpha is d omega dt, and so d omega I equals d omega d theta, and d theta dt equals I equal d omega over d theta times omega, because d theta dt is omega, the angular acceleration, the time rate of change of angular position. So the sum of the torques d theta equals d work equals I omega d omega. So the integral from omega initial to omega final of I omega d omega is 1/2 I omega squared final minus 1/2 I omega initial squared. So these are some comparisons of the rotational motion and the translational motion, all of which we've had. Comparison of omega angular speed and translational speed, angular acceleration and translational acceleration, net torque and net force. For constant angular acceleration and for constant linear acceleration, you get the equations of motion. Work is equal to torque d theta, work is equal to force x dx. Rotational kinetic energy is 1/2 I omega squared. Kinetic energy is 1/2 mv squared. Power is equal to torque omega. Power is equal to force times velocity. Angular momentum, we haven't gotten there yet, but angular momentum is going to equal to I omega. Linear momentum is equal to mass times velocity. And net torque is, or the sum of the net torque is equal to dl dt, and the sum net force is dp dt, the time rate of change of momentum. So net torque is time rate of change of angular momentum. And that's it for this section. I think I'm going to, well, yeah, let's just stop it here. I'll do another short video on the next section.